Boys and girls. Today we're going to do ratio. A ratio is a way to share an item or items unequally. All right? So what does this mean? Imagine me and my brother do a job, all right? And in total we earn $50. And we have to decide how to split that money up. Well, one way is we can share it equally. We can split that money into two parts. So it's $25. So I get $25 and my brother gets $25. But what if we do this job, me and my brother? Imagine we're washing cars and I wash far more cars than my brother. Is it fair to share the money into two parts because I did more work? No. I should get more money. And so instead of dividing by two, we're going to use a ratio instead to determine how much money each of us gets. So instead of dividing the money by two, I'm going to say, I'll propose to my brother, yo man, let's share this money between me and you in the ratio of 7-3. So this is our ratio, 7-3. And since in the sentence I said me and you, I'm the first person and my brother is the second person. So what does a ratio of 7-3 mean? Pretty basic, guys. 7-3 means for every $7 Shaq receives, his brother gets $3. Okay? It can also mean another thing. For every 7 units of money Shaq receives, his brother gets 3 units. All right? And a unit is a certain amount of money. It could be $1 or it could be $10. We're going to find that out in this question, okay? So whenever I do a question like this, I'm always going to think of 7-3 in terms of units. For every 7 units of money Shaq receives, his brother gets 3 units. So what we're going to do is we're going to draw a little graph, all right? Or a table. So we're going to say Shaq and his brother. And I'm going to draw 7 units. So I'm going to draw 7 boxes. And his brother gets 3 units. And note how I make each unit the exact same size, okay? I'm going to move all this here. Okay, now, in total, we are sharing $50. So that means between both of us, we are sharing $50. And what do you notice? How many units are there between us? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have to share $50 into 10 units, into 10 unit boxes, which is equal to $5. So each box is going to be $5. All right, so now what do we notice? Each unit is $5 and Shaq has 7 units. So Shaq receives $35 and his brother receives $15. All right, and that seems much more fair because I did more work, so I should get $35 and my brother should get $15. All right, guys, let's just do some practice exam questions from some old GCSE questions together. All right, let's read this first question, all right? I'll make it bigger. The length of an Airbus A300 airplane is 54 meters. The ratio of the length of this airplane to its wingspan is 6-5. Work out the wingspan of the airplane. All right? So we have two entities. We have the length of an airplane and its wingspan. And the ratio of the lengths is 6-5. So that means for every 6 centimeters of length, the wingspan is 5 centimeters. Or for every 6 units of length, the wingspan is 5 units. So let's draw our units out together. So we have the length and we have the wingspan. So I'm going to draw 6 units for length. I'll draw 5 units for wingspan. All right. Now, let's look at this question. What do we know? The length is 54 meters. So that means the whole thing in total isn't 54 meters. It's just the length. The length is 54. So from here to here is 54 meters. All right, and we can see that 54 meters is equal to 6 units. So we'll do 54 divided by 6 to find 1 unit, which makes 9. So 9, 9, 9, 9, 9, 9. And since all the units are the same size, the wingspan will be 9, 9, 9, 9, 9. All right, and 5 nines make 45. So the wingspan is 45 meters long, and that's our answer, guys. Work out the wingspan of the airplane, 45 meters. All right, next question. All right, let me make this larger. The perimeter of a triangle is 90 centimeters. The lengths of the sides of the triangles are in the ratio of 3 to 5 to 7. Work out the length of the longest side of the triangle. All right, so we have a triangle. I like to always draw a diagram. And we know the perimeter is 90 centimeters. And the lengths of the sides of the triangles are in the ratios of 3 to 5 to 7. So let's interpret that. So let's call the 3 sides ABC. So we can say for every 3 centimeters of length, which is A, B is 5 centimeters, A is 5 centimeters, and C is 7 centimeters. Or we can think A has a length of 3 units, B has a length of 5 units, and C has a length of 7 units. All right, so let's do our ratios now. All right, so we're gonna draw a diagram. We have A, B, C. Those are 3 sides. A will have 3 units. B will have 5 units. C will be 7 units. Okay, now let's have a look. The perimeter of the triangle is 90 centimeters. Does that mean A is 90 centimeters long? Does it mean B is 90 centimeters long? C is 90 centimeters long? Or the whole thing is 90 centimeters long? Well, what does the word perimeter mean? It means the lengths of all the sides added up. All right? So it's everything is 90 centimeters. And therefore, 90 centimeters is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's equal to 15 units. So 90 centimeters divided by 15 units is equal to 6 centimeters. So we know each of these boxes is 6. 6, 6, 6, 6, 6, 6, 6, 6. All right. Now, we can find the lengths of all the sides. Well, the side A is 666, which is 18. So we know A is 18. Side B is 6 times 5, which is 30. And side C is 6 times 7, 42. So 18, 30, and 42. So the longest side is 42 centimeters. All right, let's go to the next one. So this is just a continuation from the previous question, actually. A model is made of the Airbus A300 airplane. The length of the model is 36 centimeters. The length of the real airplane is 54 meters. Give you a ratio, find the ratio of the length of the model to the length of the real airplane. Give you a ratio in the form of 1 to n. All right, let's digest this information together. Well, there's a model, and we know the length of the model is 36. So model equals 36 centimeters. The real airplane. Oh crap, I spelled airplane wrong. Is 54 meters. And we have to find the ratio of the length of the model to the length of the real airplane. Okay, so the length of the model is 36 centimeters. And the length of the airplane is 54 meters. All right, so first we set up our basic ratio. And what do we notice, man? Well, this is in centimeters, this is in meters. So let's convert them both into the same unit. And I always prefer converting it into the smaller unit. So centimeters is smaller. So I'm going to make both these numbers into centimeters. So this just stays as 36 centimeters. Because 1 meter is 100 centimeters, we'll multiply this by 100, which gives us 5,400 centimeters. So that's the ratio of the length of the model to the real airplane. And now it says give you a ratio in the form of 1 to n. Well, so they want our first number to be 1, and we got to find n. How do we do this, guys? It's pretty straightforward. How many times smaller, or how do we get from 36 to 1? Well, we divide by 36. So ratios are always proportional. So you divide one side by 36, you got to divide the other side by 36. So, all right, so 5,400 divided by 36. What does that make? 150. So n is equal to 150. So the ratio in the form of 1 to n is 1 to 150. So we found the value of n. So this is our answer. All right, guys, last question. James and Bill are swimming laps. They swim laps in the ratio of 3 to 7. If Bill swims 60 more laps than James, how many laps did they swim in total? Okay. Well, let's look at the ratio that's been given to us, 3 to 7. So what does that mean? Well, James comes first in the sentence, James and Bill. So James is 3 and Bill is 7. So for every 3 laps that James swims, Bill swims 7 laps. So Bill's faster. James swims 3 units of length, 3 units of laps, and Bill swims 7 units of laps. So let's draw out our ratio. So whenever you see a ratio problem, guys, the best thing to do if you're stuck is just look at the ratio that's given to you and just draw a picture. So James, Bill. So James is 3 units. Bill is 7 units. And now let's interpret this information. Bill swims 60 more laps than James. So, Bill swims 60 more laps than James. So did James swim 60 laps? No. Did Bill swim 60 laps? No. Did they swim 60 laps in total? No. Bill swam 60 more laps. So where would this go in our diagram? Well, if Bill swims 60 more laps, that's just the difference between the number of laps Bill swam and the number of laps James swam. So it's basically the difference in the amount of units. So from here to here is the difference in number of laps. And that's 60 laps. And what do we notice, guys? 60 laps is the same length as 4 boxes or 4 units. So we can do 60 split into 4 boxes is equal to 15. So each box is 15 laps, or each unit is 15 laps. Yeah, I write my 5s really weird. Boom. Now, the question is, how many laps did they swim in total? Well, James swam 15 times 3, which is 45. Bill swam 15 times 7, which is, quick math, 105 laps. Yo, James actually sucks. All right, so therefore 105 plus 45 is equal to 150. Bill absolutely carried. 150 laps, guys. That's how much they swam in total. All right, guys, that's ratios. These are some pretty common past paper questions you get in your GCSE exams or just any ratio topic in general, hey? So any questions, just feel free to send me a comment or just if you have any thoughts, just let me know, all right? Cheers.